Chapter 37, Wave Optics. This is going to be the classic 7-minute summary of each of the sections in this chapter. Unfortunately, I actually recorded this video previously, except my audio messed up and it is not recoverable. So sadly, this is not my first run through of the 7-minute summary for this chapter. I have done it before, so I don't know, maybe this way might make the video a bit better, or it might make it a bit worse, but I want to shove in as much value as possible in these 7 minutes. So let's just quickly, before starting the timer, take a look at what we have to deal with. 37.1, 2, 3, 4, 5, 6 sections, starting off with Young's double slit experiment, an analysis model, waves in interference, intensity distribution of the double slit interference pattern, change of phase due to reflection, interference in thin films, and the Michelson interferometer. Alrighty, quite a lot of stuff. Some of these concepts I haven't heard before, some of them I have, but we're gonna set a timer for 7 minutes.
All right, 7 minutes, starting now.
Okay, in chapter 36, we studied light rays passing through a lens or reflecting from a mirror to describe the formation of images. This discussion completed our study of ray optics. In this chapter and in chapter 38, the next chapter, we are concerned with wave optics, sometimes called physical optics, the study of interference, diffraction, and polarization of light. These phenomena cannot be adequately explained with the ray optics used in chapters 35 and 36. Very interesting. We now learn how to treat light as waves rather than as rays. Leads to a satisfying description of such phenomena. Okay, interesting. Let's dive into 37.1, Young's double slit. In chapter 18, we studied the waves and interference model and found that the superposition of two mechanical waves can be constructive or destructive. Okay, we're going to keep pushing. Interference in light waves from two sources was first demonstrated by Thomas Young, okay, 1801. A schematic diagram of the apparatus Young used is shown in figure 37.1a. Ooh, interesting. It looks like I'm missing some stuff in this section. It looks like some stuff over here and over here has not been included. So my apologies on that. Check your textbook and see if it's included. But we have 37.1. Over here, it looks like we have Young's double slit and some red light waves coming through. And then it looks like a whole bunch of stuff is happening here. It looks like, I guess, some interference, some constructive and destructive interference. And then we see this black and red striped pattern here. Interesting. I don't know what to make of that yet. Over here we have an image that looks like it's also including, or missing some stuff, but it says constructive interference and destructive interference. And it shows us, it looks like the surface of a lake with two little ripples or like point sources of waves. Cool. All right, let's take a look at this. Constructive interference occurs at point O when the waves combine. Constructive interference also occurs at point P. Destructive interference occurs at point R when the two waves combine because the lower wave falls 1/2 a wavelength behind the upper wave. Pretty cool. This is a lot of stuff to read here, and I have 4 minutes 30 seconds. So conditions for interference, this looks important. The sources must be coherent. That is, they must maintain a constant phase with respect to each other. Okay. The sources should be monochromatic. Monochromatic and coherent. Those are bolded words. They look important. I'm going to research them a little bit later. And then we have here, light passing through narrow slits does not behave this way. Light passing through narrow slits diffracts. Okay. This is an image I'm going to try to keep in the forefront of my mind because it looks quite important. And we head over to 37.2 with 3 minutes 58 seconds left on the timer. Analysis model, waves in interference. We discussed the superposition principle for waves on strings in section 18.1. Okay, we did not read that. Leading to one-dimensional version of waves and interference analysis model. Okay, I'm not going to read all that. Let's look in more detail at the two-dimensional nature of Young's experiment with help of figure 37.5. This is kind of interesting to me. 37.5 over here, geometric construction for describing Young's double slit experiment, not to scale. The slits are represented as sources, and the outgoing light rays are assumed to be parallel as they travel to P. Okay, and it looks like we have some angles, we have theta in there. We have the distance between slit 1 and slit 2, which is d. We have r1, r2. We have y. A whole bunch of like geometrical stuff going on over here. But I don't have too much time to look at it. What I'm going to look at is these couple of yellowed out equations, conditions for constructive interference. D sine theta bright equals m lambda. Then it says m equals 0, comma, plus minus 1, comma, plus minus 2, dot, dot, dot. Okay. I see a couple bolded words, constructive interference, order number, destructive interference, a couple other things. Condition for destructive interference looks like a very similar equation. Y bright, Y dark, some equations that I cannot really look at any deeper because of the 7-minute timer, and we have 2 minutes 27 seconds. Analysis model, waves in interference, and an example, first example of the chapter, measuring the wavelength of a light source. Okay, it looks like maybe we use some of the equations that we just saw. Example 37.2, separating double slit fringes of 2 wavelengths. Not sure what that means, but there's the example there. 37.3, intensity distribution of the double slit interference pattern. Notice that the edges of the bright fringes in figure 37.1b are not sharp. Rather, there is a gradual change from bright to dark. Okay, a couple more equations look like sine. There's E, I don't know what E is. There's some delta and phi, lambda, 2 pi. Phase difference over here is quite important. This thing I have seen quite a lot, and personally it is a confusing topic, so I'm gonna just keep phase difference in mind. Maybe I'll go back to this chapter and read about like what is phase difference. Looks like a yellowed out equation over here. Yellowed out equations are pretty important. It looks like I equals I max cosine squared with a bunch of stuff inside the cosine. I'm not sure what this is. I'm assuming I means intensity. Not sure. We're gonna look at it. A couple of pictures here, and they actually show you I max and I at the top. Okay, I don't have time to look at that, but I will keep it in mind that that is about diffraction, right? Was it talking about diffraction, or was it talking about interference? Yeah, I see the word diffraction patterns here, and I don't see the word interference. Okay, we're gonna keep going. Let's check the timer. 48 seconds. Change of phase due to reflection. Okay, looks like the young double slit experiment again, sort of. Oh man, I can't read this. This looks like an important picture here. Interference of thin films. There looks like, seems to be a thin film over here. Okay. Looks like a quick quiz. Looks like a lens, kind of like a banana-shaped lens, thin film. We have 20 seconds left. Newton's rings, thin film interference pattern, problem-solving strategy. This looks important. I'm straight up going to screenshot this and read this before going to sleep because this to me looks important. Problem-solving strategies. Interference in a soap film, non-reflective coatings, the Michelson interferometer. Oh my goodness. That is the timer, and we end off with the last section, Fourier transform, infrared spectroscopy. What does that mean? And oh my goodness, another section, did not finish it in time, laser interferometer gravitational wave observatory. Crazy words and the summary there. So 7 minutes, as you guys can see, not that valuable, but it can be done in 7 minutes. Just zoom through the chapter. And unfortunately enough, look at this over here. This for sure looks like there's something missing over here. You see what I'm saying? Like there's definitely some equations here, maybe a sine or something like that. So some errors have happened in my book. But let's take a look at the summary real quick just to close off the whole chapter. We got some concepts and principles. Interference in light waves occurs whenever 2 or more waves overlap at a given point. An interference pattern is observed if 1, the sources are coherent, and 2, the sources have identical wavelengths. Okay, I remember coherent and monochromatic at the beginning of the chapter. Not really sure what coherent and monochromatic means exactly. Maybe I'll check Wikipedia really quick before going to sleep tonight. The intensity at a point in a double slit interference pattern is, and then we have this I max cosine squared equation, where I max is the maximum intensity on the screen, and the expression represents the time average. Continue. I guess it continues on to the next page, but I was right to think that I stands for intensity. Cool. Let's take a look at this section here. A wave traveling from a medium of index refraction toward a medium of index of a fraction. Okay, there's for sure something missing in the sentence. Like, yeah, there's some, maybe the index of a fraction n1 and n2 or something like this is missing. But yeah, take a look at some other textbooks if you can find them online and just cross-reference and see what is missing from this, because it is quite unfortunate that some of these equations are missing. Same thing over here. You see this sine, and then over here theta bright is missing, and the rest of the equation over here is missing. So a little bit unfortunate, but that's okay. We could at least get some concepts out of the way. Waves in interference. Young's double slit experiment serves as a prototype for interference phenomena involving electromagnetic radiation. In this experiment, two slits separated by a distance, I'm assuming D is supposed to go there right after distance, are illuminated by a single wavelength light source. The condition for bright fringes, constructive interference, and then that kind of half their equation. The condition for dark fringes, destructive interference, again, sort of a half equation. The number is called the order number of the fringe. Okay. Interesting. And then we got some questions. Here is chapter 37. We have the first page, second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16 is the summary. So overall, 16 pages. We went through them in 7 minutes, but as you can see, take a big bird's eye view of this stuff and just dive into whatever you think is most interesting, whatever you think you are struggling the most with and you need a bit of refreshment on. And of course, you don't have to just read this book. Get the starting groundwork foundation of what you have to learn for the class from the textbook. Like, for example, you could even start here, just these topics here, copy paste this into a Word or Google Doc, and then just type like Young's double slit experiment into Google, take a look at the Wikipedia page, take a look at some Reddit stuff, take a look at some YouTube videos, and just write what you think is happening here. Then you can come back to this chapter here, Wave Optics, chapter 37, and you can just fill in the missing blanks, and you can try your best to explain all of these concepts to yourself in your own way. But of course, start off with a quick little 7-minute summary. You guys can do it on your own. You can also watch my video. Don't stress about it too much. 7 minutes is not that much time. And just boom, hop on and get it going. You know, don't put it off. Don't procrastinate about this stuff. You know, just read through it. And then once you have some free time, just remember, oh, I remember that the Michelson interferometer is something that I read for my class, and I need to learn about it more deeply. I have no idea what it is, and you can just watch a little YouTube video about the Michelson interferometer and learn about it very quickly while on the bus or eating some dinner or, I don't know, hanging out with some friends. Just peep on Wikipedia Michelson interferometer. So I hope this was helpful. I know I'm kind of yapping very quickly, but that is the nature of the 7-minute summary. I hope you guys enjoyed. Once we get to some problems related to this chapter, I'm going to try to do a slower read through of the sections here that were confusing. So for me personally, the Young double slit experiment is a little bit weird. I mean, all of these things here are a little weird. Change of phase due to reflection. Personally, this thing has been really confusing to me from the start. So I'm going to read a little bit about this stuff. Maybe I'll post a video on that. And please, if you think that there are some questions or things that are confusing to you, drop a comment in this video and I will try to respond as best as I can. Thank you for watching. Have a great day. Stay hydrated. Peace.